This is section 5.7, using congruent triangles. So once we have triangles are congruent, we could use something called CPCTC. And CPCTC stands for corresponding parts of congruent triangles are congruent. So corresponding parts, that's our C and our P, of congruent triangles, that's the C and the T, are congruent, and that's our last C. So C, P, C, T, C. So we use CPCTC when we're asked to prove that parts are congruent, but first we have to prove the triangles are congruent. So in this proof, it's asking us to prove that angle BCA is congruent to angle BCA. And unless they told us that there was a bisector or something like that, I couldn't prove that those two angles were congruent. So what I would do is I would first prove these two triangles are congruent, because then any of their matching corresponding pieces would also be congruent. So we notice they put BC is congruent to BC, so we know that's given. And then the other given they didn't mention is segment AB is congruent to segment AB. So once I'm given those two things, I'm going to mark them in the picture. AB congruent to AD, and BC congruent to DC. Then they want us to use the reflexive properties. The side that's shared in these two pictures is segment AC. So we have AC is congruent to AC. And we'll mark that as well. So now in the picture, I have a side mark here, a side mark here, a side mark here. So my triangles are congruent by S, 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 or side, side, side. And now that I've proven that the triangles are congruent, we could say angle BCA is congruent to angle BCA. Notice how they match up in the congruent statement. So angle BCA is congruent to angle BCA, and that's because corresponding parts of congruent triangles are congruent, or CPCTC. All right, let's do another one together. I want to prove that these two segments are congruent. So let's first prove that the triangles are congruent. So we're starting out with the fact that PS is parallel to QR. And that's given. So if these are my parallel lines, let's draw them and connect them with a transversal. That would make these two angles congruent by the alternate interior angle theorem. So that's angle PSQ is congruent to angle RQS. My other given is that angle P is congruent to angle R. I'm going to make sure I mark that as well. Angle P with angle R. And then they have that segment SQ is congruent to segment QS, which is our reflective side. So that is reflective property. So in our picture, we have this angle marked over here, we have this angle marked over here, we have this side marked over here. So I have two angles on a side. If I connect the two angles, it did not pass through the side, so my method of saying the side is congruent is AS instead of ASA. And we have to finish the congruent statement. So they're saying QPS. So unmarked, double 1. And the other triangle, unmarked, double 1. Triangle SRQ. And now that we know the triangles are congruent, I could say that PQ is congruent to RS. And that's because of corresponding parts of congruent triangles are congruent. CPCTC. All right, another one together. We are given X is the midpoint of WY. So if I'm looking at WY here and X is the midpoint, we know by the definition of midpoint I can make those two segments congruent. So that's WX and YX. I'm also given, notice here that I had it marked X is midpoint of WY and ZB. So if I only said before that X is midpoint of WY, I need to say X is the midpoint of ZB. So another definition of midpoint now is the other segment. X is the segment of, so that's VX is congruent to ZX. Then I see angle WXB. WXB, trace it, is this angle here, congruent to YXB, this angle here. And those are vertical angles. We're going to use the vertical angle theorem. So we went from the angles being congruent to now saying the triangles are congruent. So if I look at my picture, that's a side that's marked there, that's an angle that's marked there, a side that's marked there. I connect the two sides, it points to the angle, so that is congruent by SAS. And WXB, so along the side that's one to the right angle, would be YXZ, right? Triangle YXZ. And now that I've proven the triangles are congruent, I can say any of the matching parts are, like W and Y. So angle W is congruent to angle Y. My corresponding parts of congruent triangles are congruent, or CPCTC. Yet another one together. So here we are given JM bisects angle KJL. And let's put the other given in there now. Angle JMK is congruent to angle JML. So I'm actually going to mark those first. Angle JMK and JML are here. So now let's go back. JM bisects angle KJL. So we're bisecting the angle at J, which means the two pieces of the angle would be congruent. So that's angle KJM is congruent to angle LJM. And then using the reflexive property, I have JM is congruent to JM. So if we look at our picture, we have an angle marked here, a side marked here, an angle marked here. If I connect those two angles, it does go through the side. So we have ASA as our method. And if I'm saying triangle JMK, I'm going to say triangle JML. And once again, once we've identified our triangles as congruent, we could take any pieces. So JK to JL. And that's CPCTC, or corresponding parts of congruent triangles are congruent. Finally, one for you to try. So try this problem, pause, and when you're ready to see the answer, hit play. So we are given our first statement. We have vertical angle theorem for the vertical angles to be congruent, which now allows me to say the triangle BCD is congruent to triangle FED by SAS, side, angle, side. And then angle E is congruent to angle C by corresponding parts of congruent triangles are congruent, or CPCTC. So in example 5, we want to explain how to prove the statement is true. So if I want to prove that these triangles are congruent, I'm first going to prove the triangles are congruent. So I know I'm allowed to mark this side, so I would have reflective. Then the triangles are congruent by SSS. And then angle A would be congruent to angle C by CPCTC. So I'm really just doing a rough explanation of how we would get the triangles to be congruent, so then we can use CPCTC. So in the second one, I'm really looking at this big triangle here. which if I were to draw it separately, I have an angle up here, two angles here, and this side. And I'm going to have the reverse on the other triangle. I have the double here, the single here, and that side. So I can say that the triangles are congruent by AAS. And then segment GK is congruent to segment HJ by CPCTC. So go ahead and try this final problem. Pause. When you're ready to see the answer, hit. All right, so we have vertical angles are congruent in this picture, which allows us to say that triangles are congruent by SAS, and then angle V would be congruent to angle Z by CPCTC. And that is 5.7 using congruent triangles.